And if we add 3 to both sides, get x equals 3. Excuse me. Which gives us our critical numbers. Okay, again for our second and third step, I'm going to put our critical numbers on the number line, which is 2 and 3. And we're going to pick our test values. So if we have this interval from negative infinity to 2, yes, this interval from 2 to 3, and this interval is from 3 to positive infinity. I'll bring that up a little bit. Okay. So remember, this is also equal to x, not x squared, x minus 2 times x minus 3 is greater than 0. So you can use that when you plug in your test values. It'll be a little bit easier. Here we go. Okay, so here we'll pick x equals 0 because it's easy and it's random. So you have 0 minus 2 times 0 minus 3 is greater than 0, which means negative 2 times negative 3 is greater than 0, which gives us 6 is greater than 0, which is true. Okay, so we know this is part of our solution. Okay, so between 2 and 3, you can pick x equals 2.5. And this is where not having to actually solve it comes in handy, because you just want to find out if it's positive or negative, if it's greater than 0, if it's less than 0. Okay, so if you have 2.5 minus 2 times 2.5 minus 3 is greater than 0, 2.5 minus 2 is going to be positive. 2.5 minus 3 is going to be negative. A positive times a negative is going to give you a negative. So a negative greater than 0 is false. Okay, so we know just by that being false, might as well circle that. It's not a solution, or not part of the solution interval. Okay, we do the same thing for 3 to infinity, and I'll pick x equals 4. Okay, so that gives us 4 minus 2 times 4 minus 3 is greater than 0, which is 2 times 1 is greater than 0. So 2 is greater than 0 is true. Okay, so we know this. Oh, let me separate that. It's part of the solution. Okay, so we go ahead and put those intervals in our interval notation. And I'll graph it just because you don't have to. So we have 2 to 3. So because we have the greater than and not greater than or equal to, we're going to use parentheses. Okay, so from negative infinity to 2. And we have from 3 to positive infinity, both using parentheses. Okay, so our solution interval is from negative infinity to 2, or from 3 to infinity. All right, any questions on that one? All right. Oops, slide that over a little bit. New one still writing. Looks like Okay. Now with rational equations, it's just a little bit different, only because now you have to deal with possibilities that your denominator could equal 0. So the only thing that would change is, as far as the steps, is that with your step 1, you now have to count any values that will make your denominator equal 0. Okay, so when solving rational inequalities, you want to factor your numerator and denominator. To find any critical points. And that's only if it's necessary. Sometimes you don't have to do that. I mean, you still use them as your critical points, you just don't have to factor them. Sometimes they'll come already factored. Okay, so let's say, for example, you want to solve x squared plus x minus 2 over x minus 4 is greater than or equal to 0. Okay, so for your first step, you want to solve for x squared plus x minus 2 over x minus 4. Bring that down a little bit. Is equal to 0. So that part hasn't changed. You want to find where it's equal to 0. Okay. You just have to remember that 0 divided by any value that's not 0 is going to equal 0. So as long as you have a 0 in that numerator, it doesn't matter what's in the denominator, as long as it's not 0, it'll be okay. So that means here, x minus 2, or x squared plus x minus 2 actually factors out to x plus 2 times x minus 1 all over x minus 4 equals 0. Okay. Which means for this to equal 0, either one of those could be 0. So as long as your numerator is 0, this will equal 0. So that means that x plus 2 equals 0, or x minus 1 can equal 0. Okay. So you have x equals negative 2, or x equals 1 if you add 1 to both sides. Okay. So these are your critical points. Okay. Now the only difference here is that we now have to where x can equal 4, because that will make the denominator 0. So that will also be a critical point. So since x minus 4 can equal 0, which means that x can equal 4, x equals 4 is also a critical point. Okay, so in this case, you have 3 critical points now. Okay, which means you have to place all 3 critical points on the number line and find test values in between all of them. All right, so if we get our second and third step, we place our critical points on the number line. So we have our negative 2, we have our 1, and we have our 4. Oops. And again, just draw a little dotted line to kind of separate them. Okay, so that third critical point Just gives us a little extra work. Okay, so this interval is from negative infinity and stops at negative 2. This interval is from negative 2 to 1. This interval is from 1 to 4. And this interval is from 4 to infinity. Oops, separate that a little bit. There we go. Okay, so now we just pick our test values. And let's, did not put test. Let me say pick for this one, x equals negative 3. Okay, so remember, if you wanted to, you can also use, I'll put it in a little box here, because we factored it, x plus 2 times x minus 1 over x minus 4 is greater than or equal to 0. So you can use that to plug into your test values. Oh, leave that down in case you were. Really all it is this one, but saving it back greater than or equal to. Okay, so that gives us negative 3 plus 2 times negative 3 minus 1. Oh, clean that up a little bit. All over negative 3 minus 4 is greater than or equal to 0. Okay, so that gives us negative 3 plus 2 is negative 1 times negative 4 all over negative 7 is greater than or equal to 0. So here you'd have a positive divided by a negative greater than or equal to 0. Oh, make that a little bit neater. Positive divided by a negative is negative. So a negative is greater than or equal to 0 is false. Okay, so we know this one's not part of the solution. You can put not part, or you can just put no, or anything to let you know that you're not going to use that interval. Okay, now between negative 2 and 1, just pick Old Faithful, x equals 0. Okay, so if x equals 0, that gives you 0 plus 2 over 0 minus 1 over 0 minus 4 is greater than or equal to 0. Which gives you 2 times negative 1 over negative 4 is greater than or equal to 0. 2 times negative 1, if you don't want to solve it out, you just want to know that negative divided by negative is greater than or equal to 0. Negative divided by negative is positive. So if you have a positive is greater than or equal to 0, it's true. Okay. So we know this one is part of the solution. Excuse me. Okay. So from 1 to 4, I'll pick x equals 2. Okay, so that means we have 2 plus 2 times 2 minus 1 all over 2 minus 4 is greater than or equal to 0. So we have 4 times 1 over negative 2. 4 times 1 is 4, divided by negative 2 is negative 2. Negative 2